Hello and welcome to my talk about amplifying AI productivity and trust with Morphir. Thank you for coming. I know there's a lot of interesting presentations going on, even at the same time with this one. So I hope it will be well worth it for you. So before I get into the presentation, a few things about myself. I'm a software developer at Morgan Stanley. I've been working there for a pretty long time. I'm also a co-creator of Morphir, which is an open source project managed by FINOS. My interests are programming language design, functional programming, domain-driven design, and business logic transparency. This last one might not be that familiar to you, but you'll see what it means during the presentation. So I know it's after lunch and everything, but sorry for that, but I'll start with a quiz. You'll actually have to think a little bit. So if you look at this number, does it mean anything to you? Is there anyone? Hands up. Yeah, okay, I can see a couple of hands. Yeah, so I was hoping that there are a couple of sci-fi fans. Yeah, so 42 is the answer to the ultimate question, at least according to the Hitchhiker's Guide to the Galaxy. So if you can't recall it or you don't know the story, I'll quickly go through it. So this is the story of Deep Thought. Deep Thought is a supercomputer that was built by a highly intelligent species. It was built to find the answer to the ultimate question. And after millions of years of computing, large crowds gather, and all it produces is 42. And you can imagine the crowd is very confused, and nobody understands what that answer means. But of course, nobody knows what the real question was. And I just want to keep that feeling in mind, because the story of Deep Thought is actually the reality for our business users a lot of the times. So we build these highly complex computer systems with a lot of complex business logic in them. And then what our users see is the end result. And often they won't understand exactly how the system came up with that result. Luckily, software developers, us, we are there to help, and we can figure out exactly what the system did and why it answered with that, why it gave that answer based on the business logic, at least for now. And of course, we are in this room because there's been an AI revolution, and so we have vibe coding now. And if you look up the definition of vibe coding in Wikipedia, it says that it's a necessary part of the definition that the developer accepts code without full understanding. So the situation got worse. Our business users didn't know what that number meant or how it was produced, and now we will not know how it came around as well. Of course, I mean, it's not as bad as it sounds, and I'm not saying that we shouldn't use large language models. There's obviously a bunch of productivity gains. They are fast, they are relatively cheap, they evolve over time, but the trust becomes a question. So it becomes a productivity versus trust question. We know that they hallucinate. We know that they do one-off mistakes, just like people do. And just like people, with more code, there's going to be more bugs. And also, just like people do, or human developers do, we mix business logic with infrastructure. And that's exactly what the LLMs do, at least when you use them in vibe coding style. So the question is, can we retain the productivity without losing the trust? And this is where Morphir comes into the picture. So Morphir is an open source project that I mentioned is managed by FINOS, and it was originally contributed by Morgan Stanley. And it's centered around this intermediate representation that is essentially a data structure that captures the business logic. And why that is interesting is because then that can be used to do interesting things like visualizing the business logic to non-technical users, and also be able to execute it on various platforms. I will focus more on the visualization aspect of it, but what comes together with Morphir is basically a strict declarative language that gives us controls. It's so strict that it doesn't allow runtime exceptions at all. And on the transparency side, we have the human-readable visualization. Now, there's one caveat with all of this, so far at least. The barrier to entry was pretty high because in order to get to that Morphir IR, you had to go through a language syntax that only developers understood, and only certain ones of them. But what happens if we replace that syntax with natural language, combining it with AI? And we don't have to guess. I actually have a live demo to show that. Actually not live, because I pre-recorded it to make sure that I'm not running into any technical issues. But basically what you'll be able to see here is I have Claude Desktop on the left side, and I have Morphir Web on the right side. And they are connected using the MCP protocol. If you don't know what MCP is, that's the Model Context Protocol by Anthropic. It's a pretty new thing, but it's basically a way to connect your existing applications or whatever tools you have to LLMs, so that LLMs can use it as a tool. And so what I'm going to do here is basically simulate what a business user would do if they wanted to solve a business problem. So what's happening here is I created a prompt. It was completely made up for a business use case. It was actually generated by an LLM, so it has no relationship to reality, for auto-approving trades. And I'm not going to read the whole thing, but basically it describes all the rules about auto-approvals. And I send it to Claude. As I mentioned, Claude is now connected to Morphir. So it understands what it can do with Morphir and starts implementing the code. You can see that that's happening there, but it will actually hide it because that's not important, because everything is happening in the background, and what you will see is the visualization coming out of it. What it's doing now is actually adding test cases, because that's another tool that was exposed through Morphir. And so far it looks similar to what you do with vibe coding. The difference, though, is in the next step, when we refresh Morphir Web, it already shows the business logic as that was created. And you'll see that it turns into a decision table with nested decision trees in it. And that already is pretty nice, I think. But it also created these test cases, so we can immediately start going through those test cases. First of all, verify if the expected results are, the results are what we expect, and also follow through the execution path as we click through it. So that's already impressive, but of course, we don't just want to create these once, we also want to evolve them over time. So as a next step, I'm going to ask it to extend into the world of cryptocurrencies. And so I'm typing that in right now, and you will be able to see that it's doing a very similar thing now. It again goes in, changes the code behind the scenes, and after it refreshes, you will see that the business logic and the visualization with it has updated. It also, right now, it's actually adding more test cases. And what's important here is that we are using that strict language. So the LLM is under control. It can't do crazy things. There's a bunch of stuff that the language doesn't allow it to do. So what comes out is guaranteed to be visualizable. So you'll see refreshing there, and there's now the cryptocurrency handling. And it also created more test cases as well, but that I guess is not that important anymore now that you saw that it does that anyway. So going back to the presentation. So what you've seen is that the combination of AI and Morphir brings productivity and trust. The AI brings a natural language interface and translation of business problems to technical terms, and Morphir brings the controls through a very strict language and the transparency through business logic visualization. And I get this question a lot, why not just generate directly to Java or Python? Now, I took a screenshot because I actually tried that. I took the exact same prompt, and I asked Claude to actually generate it. Of course, I turned off the Morphir integration, and I asked it to do that in Java. And you can see all the things that I mentioned previously. It's basically putting test cases into that code. It's doing, well, I could call it infrastructure, but you can see it's doing writing to the console and all kinds of stuff. And of course, it doesn't produce the visualization that is understandable by a business user or just a non-technical user. So also, in general purpose programming languages provide more freedom to developers. So that's why developers like to use them. And when we are thinking about tooling, we have to think about how people feel. But with large language models, we don't have to think about that. We need more control than freedom. They won't complain if we put controls on them. And we actually should do that in this industry. And so one example of how to put controls over it is Morphir guarantees no unhandled cases. With a language, general purpose programming language like Java or Python, they leave room for runtime errors. We all know we get null pointer exceptions all the time and the such. I wanted to highlight another aspect of it is that when you put constraints on user code, that provides a lot of freedom on the platform level. So that's exactly why we can visualize the business logic that is written in Morphir, because it is a constrained language. So we don't allow a lot of things that general purpose programming language allow, like mutation and parallel processing and stuff, which would be incredibly difficult to visualize. That's why there's no tool out there that would do that. And then AI should do what it's good at, the natural to technical language translation. And developers should do what they are good at, building scalable, reliable, and maintainable systems. So it's a much nicer setup where you have both doing what they are the best at. And to wrap up, large language models can accelerate software creation, but we need transparency and controls in order to make that realistic. And Morphir adds that structure and the visualization that creates trust. And the combination of the two enables trusted AI-driven collaboration between subject matter experts and the systems. And I also wanted to mention that everything that you saw was using open tools. So Morphir is open source. That specific MCP server that was driving this is not in the main repo yet, but it will soon get there. And you can try it out. And you can, of course, contribute, which would be highly appreciated. And so with that, thank you, and I'll open it up for questions. Any questions? Yep, go ahead.
So do you basically not use any LLMs for when you actually run them? You basically run the MCP and then connect to Copilot or you're using Fine. And then the code that is generated by the LLM is run by the MCP. So how
Yeah. Yeah, so basically the question is about like the details of that interaction between the LLM and Morphir through the MCP server. So specifically what's happening there is we have a programming language that we use as a modeling language in Morphir called Elm, which is a very strict language. And basically, what the LLM does is it generates the code in Elm and sends it over to Morphir, and basically Morphir processes that, validates it, and then creates that Morphir IR that I was talking about that is then used for the visualization, but it also generates into Scala and Apache Spark and various other execution platforms. That transformation is not done by the LLM or any LLMs. That is code that people wrote to do the translation between the intermediate representation and the execution language. So there's a benefit there that's verifiable code where you can check if that's actually the translation is correct or not. And it's going to be consistent over time. Yeah. Any other questions? Yep.
Do you think it would be possible to go in the other direction and use like an MCP integration to begin to ask questions about the logic already in Morphir?
Okay, yeah, so the question was whether we could flip it and essentially ask questions about the business logic. And the answer is yes, of course, and that's actually a great idea. Yeah, so it only takes another step. So the MCP protocol has a bunch of different building blocks in it. I only used like one building block. One of the other building blocks is a way to provide information to the LLM about something else, and that could be used in order to achieve this. So, yep. Any other questions? Yep.
Are you not limited by the capabilities of the language which you have, or the programming language?
Yeah, so the question was, are we not limited by the capabilities of the programming language that we chose? And the answer is yes, and those are intentional limitations. Usually, so the first thing to mention is that it's a Turing-complete language. So technically, there's no problems, no computational problems that you couldn't solve with it. But it is intentionally limited. You can't read from, there's no I/O. There's no parallel processing. You have basically zero control over how your code executes. You are only allowed to describe what your code should do and not how it does it. Yep.
So let's say we have to use it. How do we migrate our existing application or existing code into this platform?
Great question. So the question was, if you wanted to use it, how do you migrate existing applications or existing code? So the answer is like you can just feed it to the LLM. The same way I prompted the LLM using business language, you can prompt it using any other language. Basically just saying, okay, implement this, and then it will essentially translate whatever language you are feeding into Morphir. So, any other questions? Yep. So the question was, is the code available in GitHub? So all the visualization and everything, what I had on the right side basically is available. The integration between the LLM and Morphir is not yet, but it's basically on my branch waiting to be merged. So it's going to be available pretty soon. Yep.
Morphir seems really good at visualizing the business within one application.
Mm-hmm.
Are you planning to extend it or otherwise enhance it so that you could see the business logic from a more complex system or from a framework system?
Mm-hmm. Yeah. So the question was, Morphir is good, seems to be good at visualizing a single application, but are we thinking about expanding it to cover multiple or larger systems, combining multiple applications? And the answer is yes, we are continuously thinking about that. We are an open source project, so we are limited in terms of resources, but that's actually a good topic for a contribution, so you're welcome to join our community calls. Yeah, so we have been thinking about that for a couple of years, but the way we are thinking about all these, like the migration to Morphir, is that we like to do that from the inside out, right? So a lot of these big migrations happen from the outside in. You start looking at the whole picture. Here, well, the idea is that you put Morphir into each application, and eventually, as they grow, they will meet at some point. Any other questions? Yep.
How does it understand the IR representation? Like, do you push the docs in the context window for that to happen? To actually understand, or is it just because it understands Elm, it can generate it can generate the IR?
Yeah.
And the second question is, what did you use for eval? So how do you know it's actually generating the right sort of representation based on prompts, or do you use some sort of evaluation strategy to actually check the, what is the hallucination levels, what the correctness of what is generating?
Yeah, so the first question was, sorry, can you repeat it?
How do you give it the definition?
Oh, yeah, so yes. Yeah, so the first question was, how do we provide the specification for the language? How does the LLM know what to do? And the answer is, it already knows Elm, yes. Most of the LLMs already know how to code in Elm. But even in the description of the MCP server, there's extra instructions about what to pay attention to, and the LLM just follows those. So that part was pretty easy. And then the second question was, how do we evaluate the correctness of that translation, and yeah, what's the evaluation methodology? The answer is, it was ad hoc for this presentation, right? So basically just looking at the prompt and checking if it actually did what the prompt was saying. But there's, as you saw, there's test cases generated as well. So eventually a human will have to verify that it's doing the right thing. It's just like nothing else to go by, right? But we haven't run any extensive evaluations on how much better it performs than just vibe coding. But based on the strictness of the language we have, and like the limitations of the environment, we have reason to believe that it's going to be a much higher percentage in terms of accuracy than just regular vibe coding.
And another follow-up is, what artifact are users checking in? Are they going to be checking in the natural language description of what they wrote? Or just the Morphir IR sort of representation? Is that being checked in? So,
Yeah. Okay. Yeah, so the question is, what is the development, like essentially the SDLC aspect of this? What are people checking in? Is that the prompt itself, the natural language prompt, or the Morphir IR? And the answer is we haven't really figured out. We have to think about that, I mean, as a community. I would say that it would make sense to check in the Morphir IR, because that's a bit more solid in terms of like semantical correctness, and you can always generate a description of it very easily using an LLM, but maybe both, I don't know. We'll have to figure that out. Any other questions? Sorry, did I see some? No? Okay, thanks again. Thanks for coming.